2013 question 1. You can pause and read the question for yourself. We've got 2 teams taking part in a competition. Best of 3 competition. Each game continues until one team has a winning score. The team that wins 2 games wins the competition. So if we begin our first game, either A wins or B wins. They're evenly matched, so the probabilities are going to be 0.5. A wins, B wins, A wins, B wins. Same probabilities. That's the second game. Now, this branch we can actually stop because A has won 2 games, and the team that wins 2 games wins the competition. So over here, we'll write down which team has won. Now, this one here, we can have another game because it's the best of 3. So A wins or B. And clearly this one we can stop as well because B has won 2 games. B would be the winner of the tournament that way. Now, going down that branch, A has won twice. Down this branch we've got B winning twice, A winning twice, and B winning twice. Probabilities are all 0.5 because they're evenly matched. Part 1, find the probability that Team A will win the competition at the end of the first 2 games. So probability of A winning at the end of the first 2 games, that game, first game, second game, multiply down the branches, 0.25 or a quarter. Right, part 2. We're probably going to need the tree still. What is the probability that the winner cannot be decided until 3 games have been played? So we want the probability of getting through to 3 games. There's 4 ways we could do that. Multiplying down the branch each time. And there's 4 of those. We could have done it to the power of 4. Or times 4 actually. And working all that out, that comes to 0.5 as well. Right, part 3. Now we might lose the tree for a little minute here. Okay, we'll just reduce this a little bit. And you can pause and have a read. This time finds that the probability of either team winning at their own school is 3/4. So it's like having home advantage. So if you play at your own school, you've got more chance of winning. So the first game here is played at school A, so the probability of A winning is 3/4. Of course, probabilities on the branches add to 1. Now the second game is played at B, so B has the home advantage, so it's got more chance of winning. Three-quarters down there for B, we'll move it up in a minute. A has won the competition that way. Third game. It's played at school A, so A has the home advantage, it's got more chance of winning. The winner moving down this way, we've got A, B, A, so A's won 2 games. Remember, you have to win 2 games out of the 3. And of course we'll move it up now and have a look at the last branch. Try and fit the last branch in. B's won 2 games there, so it stops there. More chance of winning when you're at home. Right, part 1. What is the probability that A wins the competition? So we've got that branch, and that branch. We multiply down the branches and add the ones we want. So this branch is going to be a quarter times, or 3/4 times a quarter. This branch is 3/4 times 3/4 times 3/4. And this branch here is 1/4 times 1/4 times 3/4. You can change them to decimals, you could use the fraction button on your calculator, but once you've got answers for all three, you need to total them up. And the answer should be 0.65625, and you can do some rounding on that. Right, we'll see how much space we've got. Oh, we've done that one. Right, so next page. If Team A wins the competition, what's probably the winner would not have been decided until the end of the third game. In other words, what's probably they need 3 games. So here's the magic word if. That's what I'm given. I'm given that Team A wins the competition. So we want the probability that if A wins, we want to find the probability that it took 3 games. Now, remembering probability from trees, the part that we're given becomes the denominator, so we want the probability of A winning. And on the top we want the probability of 3 games happening and A wins. Right, so looking back up here, probability that A wins we've got, 0.65625. And on the top we want the probability of 3 games happening and A wins. So 3 games happening and A wins would be this one and this one. They need 3 games and A wins. 3 3s are 9, 3s are 27. That's 27 over 64. You can work that one out. And this one here is 3 over 64. So adding those two together, 30 over 64. You can work it out as a decimal. Using brackets, being very careful with my division, we end up with a decimal of 0.71429. Right, part 3. Team A is almost twice as likely to win the competition as Team B. Is that justified? So, probability that A wins, we've already worked that out. It's 0.65625. So we need to find the probability that B wins the competition. So going back up the top, we want to find all the ways that B wins. We're going to have to multiply down the branches. So if we just change that, probability of B winning, we've got this branch here, so that's 3/4 times 3/4 times a quarter. Plus, we've got this branch here, 1/4, 1/4, 1/4. Plus, B wins on this branch, which is 1/4 times 3/4. So putting all that into your calculator, hopefully we end up with 0.34375. You can try it on the calculator. So if we look at the relative risk here of A winning compared with B, probability A wins compared with the probability that B wins, and of course there are other ways you can do it. Equals 1.9. So almost twice as likely would be correct. So we'd need to write yes, his claim is justified, as A is almost 2 times as likely to win as B. And in brackets we'll put actually 1.9 times as likely. Right, next question. 3 games need to be played to decide the winner of the competition. First game is played at A, second at B, and that's probably a bit far away, and the third one at A. Probably of either team winning. So A wins or B wins. A, B, A, B, and we know we can stop there, there, same rules. The probability of either team winning a game played at their school is P. So the probability of A winning at their own school is P. The probability of B winning at their own school is P. Now we're at school A, so the probability of A winning at its own school is P. And obviously on the other branches we'll get 1 minus P. Right, show that the probability team A will win the competition compared to the probability B team will win is that. So we want to look at the probability A wins compared with the probability B wins. So the probability of A winning, if we check out who's won, so the 2 branch there is A winning, A that way, B, A, B, and B. So the probability of A winning, down this branch here, we've got P times 1 minus P plus. Working this down this branch, we've got P times P times P. That's easy, that's P cubed. This branch here, we've got a 1 minus P times itself, so that would be 1 minus P squared times another P. We want to divide that by the probability of B winning. So coming down B's branch here, P times P is a P squared times a 1 minus P. Just a bit of early algebra. Coming down this branch, we've got 1 minus P all cubed. And lastly down this one, we've got P times 1 minus P. So we'll move that down a bit. Remembering this is what we've got to get to. Okay, let's go back and read the question. It says that 3 games need to be played, so actually we're not having that branch and we're not having that branch because 3 games need to be played to decide the winner. So that will mean we won't need that one and we won't need that bottom one. Right, what have we got? Doing a little bit of rearranging. On the top line I can see we've got a common factor of P, leaving me with P squared plus 1 minus P squared. And on the bottom line we've got a common factor of 1 minus P. Pull that out the front. Of course that's a squared because I've got 1 there, times that one would give me that one. Now if you look closely, this bracket on the top line and the bracket on the bottom line are the same, so we can cancel those out, leaving me with P over 1 minus P, which was the proof that we were asked for. So fairly difficult, have another look at that.